This, it's okay if it's a tripod, right? If it's a selfie stick, then it's a little dorky. Okay, whatever. I don't go by your rules of what's dorky or not, obviously, right? I make my own definition of that. Okay, so looking at these questions, let me make sure that the virtual students can see them. I'm so bad at this because everything's in reverse. Okay, looking at these questions, think about those. We're going to discuss them. But while you guys are thinking about these questions, you can write down answers if you'd like, or you can just mentally think about them in case I call on you. You know what to say. Once you're done with that, read the lab, okay? So that you can understand the lab when I tell you what part you're going to do in the lab. So while you guys are doing that, I'm going to come around. If you have your hand up and you got that homework done, and you don't want to drop it into Michigan Virtual, you want to drop it into my little green pen right here. I can report it on Skyward by you just showing it to me in class. So raise your hand if you want that to happen.
This is a good idea. I like it.
Yeah. I come up with good ideas every so often. Got it?
It's an auto forward.
Flip. Anybody else over here?
I hate that.
Yeah, I know.
Well, then why don't you finish it and submit it?
I didn't know if you wanted to.
No, I mean, if you submit it sometime today, you're good. So don't show it to me if it's not done.
Never mind.
Yeah. Okay. Thank you. Behind you. Addie. Okay. Anybody else?
There's some.
Flipper. Here. Thank you. We got Lloyd, we got Ethan. No poop today, huh? It's ABS. It's ABS. Anybody else? All right, anybody else? Want points down? Drop it in. Got it down in my green pen, and I'll transfer that into Skyward. Great. Okay, let's chat. You guys ready to chat? Ready to tell me what's in your brains? Okay. Let's start off with these questions, shall we? So remember when we're having chats like this, it's okay if you're wrong. It's okay if you're wrong. Don't even worry about being right or being wrong. I'm just trying to figure out what's in your head, okay? So that you can enhance it or affirm it or fix it. But wherever you are is fine. We're all in different places. We're all going to get to the same place by the end of the lesson, though. First question says, how do cells get what they need to survive? Start us off. Volunteer. Anything at all. How would a cell get what it needs to survive? Caden?
The bloodstream transport oxygen and other nutrients to cells.
Okay, so Caden said that cells need oxygen and nutrients. Once we get down to the cellular level, how would the oxygen and nutrients get inside of the cell? Volunteer. Yep.
Passive diffusion.
Diffusion. Okay, good. Passive diffusion. This is Adam. Okay. What does that mean? Adam's right, but can someone say what that means? How does the cell get things that it needs, like, let's say, oxygen or water? Alex?
The inside of the cell is a low concentration of like whatever nutrient or like gas is being absorbed from the high concentration area.
Okay, so he said things move from high to low. We're going to get to that in the next question. Good. So what can you say how they get there, though? Like, what are they? I don't want to give it away. So you guys are so close. You're practically saying it. You probably think that you're saying it, but I'm looking for the method that those things get into the cell. Lloyd, were you? gonna say something?
Oxidizes food molecules.
Okay, so we're gonna talk about breaking down the food particles when we get to cell respiration in the mitochondria. So hold on to that thought until we get to that. I'm trying to make that leap of they went through the bloodstream and then they diffused. What does that mean? Define what that means exactly. Caden, do you know what I'm talking about?
Osmosis?
Okay, so osmosis is how what moves into the cell. What's osmosis specific for?
Water.
Water. Good, and we'll talk more about that in a second. So that's how water gets into the cell. But can you explain what that means? Is that what you were you going to say osmosis too?
I was gonna say, like, I wasn't very specific, but I was gonna say that it, like, goes through the cell.
That's what I was trying to get you guys to say. Yeah, I think you guys all knew that. You probably just didn't say it, right? So these things are moving through the cell membrane. Where is the cell membrane? On the outside of the cell. Okay, good. All right, so that was great, number one. Number two, we kind of talked about already, right? We defined osmosis. Osmosis is the movement of, yell it out, water from an area of high to low. Good. Okay. So osmosis is specifically water. Let's go back and do diffusion. Remember yesterday we did the demonstration, 2 days ago? I can't remember. We did the demonstration of the dye in different temperatures of water to show you an example of diffusion. Can someone reiterate what diffusion means to them? It doesn't have to be a book definition. Eli? Yes, it has to do with the kinetic energy in molecules. What is the kinetic energy doing to those molecules? Anyone want to try and add to that, Alex?
Making them speed up so they bump into each other and then they like separate more.
Making them separate more. Good. So the molecules are, again, any molecule, right? Osmosis is a specific type of diffusion. So for diffusion, it could be any molecule that moves from an area of high concentration to an area of low concentration. Good. Just remember that definition. That's the book definition of it, right? I like hearing your word definitions because then that helps the other students understand it better. Okay, last question is new. This is what we're going to investigate today, okay? So take the information that we learned in the previous lessons so that you can maybe figure out this question. First off, did you guys know that cells are small? Okay, so you did that beginning part of that microscope lab and you knew you had to use a microscope to actually see them. So that should tell you that they're small. So my question to you guys is, why are cells small? I haven't taught you this, but think about that question and tell me what you think to start off with. Someone share, why do cells need to be small? Start us off, please. Adam?
So we can fit more in our body.
So we can fit more in our body, okay? So if we were big, if the cells were bigger, we'd need to be bigger, right? Why aren't we bigger then? Why aren't we like dinosaur size?
Because we're completely made of cells.
Okay, because there needs to be a lot of little things in us to make us. Is that what you're kind of thinking? Alex?
Like if an organism is too big, it has to eat like way too much food to keep up with its energy consumption, and it ends up just dying out because there's just not physically enough food in the environment.
Okay, so if we had to sustain really big cells, we need a lot of energy for those really big cells, and that might not be easy to do. Okay. Why are cells small? Good rational explanation so far. Let me hear what else you're thinking. Add to that? Yeah, it's okay.
Because they're made of, like, a really pure form. Like, the organelles aren't, like, an actual cell. They're, like, well, they're complex. They're not, like, as large.
Okay.
They're made of such tiny things.
Because their building blocks are like kind of molecules, right? So the molecules are inherently small. So if their building blocks of the cells are small, maybe that's a reason why. Okay. Logical thinking. Anybody else? When you were thinking about this question, why are cells small? What were you thinking? If we didn't kind of already touch on it. Yep.
Does it have to do something with atoms?
Yeah. I mean, everything has to do with atoms, right?
That's,
Yeah, it does. And the kinetic energy that you were talking about before. Okay, so what we're going to do today is we're going to answer this question, okay? So we're going to come back to this question. Yep.
Is it because of the kinetic energy of some different cells keeps those type of cells different from like other cells?
Well, all cells are small, right?
But
So,
they're all different, correct?
yes, all cells are
So
different.
wouldn't the kinetic energy of cells that are somewhat similar or the same keep those cells together from completely different cells? Is that what it's saying?
Well, let's do this, and then we'll look at that question again, and then maybe that'll
Okay.
help, okay? All right, so grab your labs. I'm gonna grab a lab too. Okay, and let's look at the introduction, which I asked you guys to read already, so I'm gonna kind of summarize. So what we're gonna do is we're going to use agar cubes to represent 3 different cell sizes. So we're gonna have big cells. This is our big cell, okay? So you might be assigned a big cell, and I have enough for you to do 1 or 2. Like I have so many left over. You guys are the last class of the day. So if you want to do more than 1 cell, help yourself. I'm going to tell you what cell I need you to do, and then if you want to grab another one, well, I'll explain that in a second. Let me just explain the whole lab, okay? So what we're going to do in this lab is we're going to look at simulations of 4 different cell sizes. A 4 centimeter cell, a 3 centimeter cell, and a 1 centimeter cell. Now these cells are kind of special. We've manipulated these cells so that they can clearly show us the diffusion of nutrients or whatever it might be, whatever a cell might need. We said it needs nutrients, oxygen, and we said water. Caleb said water, right? So those are the things that would need to diffuse into the cell. Caden, why do people call you Caleb? I got that in my head one day and then I just can't get it out. Sorry about that. All right, so how are we going to see what's diffusing into these cells? Well, we're going to use a little chemistry, okay? So we have created these agar cubes. Agar is something that we use in biology. It's kind of like a jello, and we put them on the bottom of Petri dishes. Have you guys ever seen Petri dishes before? Maybe not, because you've never had a biology class. Does anyone know what Petri dishes are for? Yeah. Yeah, you culture bacteria on Petri dishes, okay? And the reason that the Petri dishes can grow the bacteria is because they put that nutrient agar. It's like a jello. It's a nutrient jello for the bacteria to eat, okay? So we use that agar to make cubes. And in the cubes, we put an indicator. What do indicators do, everybody?
Indicator.
They indicate stuff, right? Makes sense. So this particular indicator indicates the presence of an acid or a base. So right now, we made it kind of basic so that it would turn pink. And then you guys are going to put an acid on it, so that's going to cause the indicator to change color. Now I know that sounds really exciting chemically speaking, but this is an acid that you probably have in your kitchen that you use to make dressing out of. Does anyone know what that might be? Maybe you smelled it when you came in the room? Vinegar. We're going to pour vinegar over these cells. Vinegar is acetic acid. It's not a caustic acid. You can get it on your skin and you can eat it, right? But we're not eating anything in the lab, okay? No eating anything. But it's not. What I'm saying is it's not harmful. We don't need to wear goggles or whatever, okay? So you're going to cover your cell with vinegar. Just pour enough in your cup so that it covers the cell, right? The pretend cell. And then we're going to let it sit. And as that vinegar, that acid, diffuses into your cell, you're going to see how much it diffuses in because there is going to be a color change. Now, this isn't a dramatic color change. It goes from being pink all the way to the edge to not being pink. It's going to turn its normal agar color, which is like, flavorless gelatin color. So it'll be clear, okay? So I wish it would turn like a fun color, but it doesn't. It just turns clear. And then what you're going to do after 5 minutes of letting that vinegar soak into that cell, you're going to cut that cell in half. You guys, I need you to close your computers because there's no reason why you should be looking at your computers unless you're not paying attention to me. All right. You're going to cut your cell in half, and then you're going to measure how deep it diffused so that we can use that to talk about why cells are so small. Okay? That's the task at hand. So, with that being said, you guys didn't see all those numbers, did you? With that being said, I'm going to give you guys cells, knowing that if I give you a size of a cell, I have plenty for you to grab extras, okay? So I'm going to hand you one, and if you want to grab an extra, this tray is filled with extras. So if you get a small one and you want to look at a medium one or a large one, if they're available, feel free to take it, okay? So you can take 2 if you'd like. So when I call your name, you're going to come up and grab your cell. And then you're going to take your cell, if it's in a paper cup, you're going to take your cell over here to this area. This is the area for the people with the paper cups to fill with vinegar. Okay? So, will you do me a favor? When you have used the beaker, put it down here, okay, so that we know that these are dirty and these are clean up top, okay? So you're gonna cover your cell with vinegar, and then you're gonna take your cup with your cell covered in vinegar back here. And then back here, you can grab a razor blade to cut your cell in half. You're not gonna cut your cell in half until it's been soaking for 5 minutes, but you're gonna grab your tool that you're gonna use for that right here. If you don't wanna use a razor blade, you can also use a plastic knife. And then you're gonna grab a 3x5 card, which I'm gonna put right here, and you're gonna head back to your seat. At your seat, you're gonna put down your cup with your cell and vinegar and your apparatus to cut it, and you're gonna press start on your 5-minute timer, which means right now in your Chromebooks, you guys have to open them up and open up a timer program and set your timer for 5 minutes. So when you return with your cell, you can soak it for at least 5 minutes. It's obviously going to be a little bit longer than 5 minutes, and that's okay. All right, sound like a plan? So you said the people with paper cups are going over there. That means if you get a plastic cup, I'm going to have you head over here, just so we're not all on top of each other. You're going to use this vinegar right here if you're using a plastic cup, if you have a big cell. Know that for this part and that part, you can stand on either side of them. You don't create a line and go slow. Stand on either side, that's fine, okay? All right, there is hand sanitizer. If you'd like to use that before you touch things, feel free. Okay, you guys ready? Let's start off with Eli. Eli, we can either go big, small, big or small. Wherever we start with you, we'll go with everybody else. What do you want?
So also, how
Want a
much?
big
are
one?
we- Yeah, how much are we supposed to pay for the big ones? Is it just supposed to be like?
Yeah, for all of them, just cover the cell.
Okay.
Okay?
So it's like-
See you over there. All right, so Melody, you need a medium. And again, if you want a different size, anything from this tray you can take if you want to try a couple of them, okay? Max, come on up. You need a small. Lexi, big. Come on up. Evan, you're going to get a medium. Izzy, come on up. You're going to get a small. Isabel, I'm just snaking around the room. Sorry. Isabel. And now Adam, you're going to get a large.
Can we set them down below and use them? Because it's
Not for those. I don't have enough to do that. Just sterilize.
That's pretty good.
Drew, you're going to get a medium. Addison, a small. I'm mostly saying this out loud so I don't make a mistake. Ryan, you're going to get a large. Okay. Madison, you're going to get a medium. Come on up.
So I'm pouring the vinegar in here and
Correct. Kaden, small.
Lots of pain.
No Regina, no Hannah. Isabella, come on up. You get a large. And remember, if you wanted a different size, you can get a second of any of these because they're all up here. Bracton, medium. And then Megan. Isabel, what size did I give you? Okay, yeah, you need to be over there. Okay. And so that means Megan needs a small. Megan, there's a good one for you.
So with the large,
Alex, come on up.
with the large ones, what do we do after we put the vinegar in?
You need to get something to cut it in half from the back sink and set your timer for 5 minutes.
We start it?
Yeah, start it right away. And then Mason, you need a medium. Mason's not here. Kara's not here. Cooper's not here. Lloyd, come on up. You need a medium. And then Ethan, come on up. I'll give you a small. And then everybody should have a cell, right? Oh, I'm sorry, Haven. You're not on my seating chart. What size do you want?
I don't care.
I'll let you choose. Come on up. Any size you choose. From this one? Yep. Anybody want a different size? You can come up. These are all available if you want to try a different one, different size. Quickly, yeah, we're gonna need you to help us with this lab. Okie dokie. So everybody's timers are rolling. You have your apparatus to cut them with. You have your 3x5 card to lay them on when you're done. If you didn't get the 3x5 card, I will give you an opportunity to do that again once we move to the next step together as a class. Okay, so now, if you're still in the process, that's okay. I'm going to give instructions on what we're going to do next. Medium? You got a small or medium? Just soak that one again. Yeah, you see what happens, take them both. You can pour, I guess you could pour the vinegar in that cup on top of that cup too. Just trash the other one. Can you do me a favor, Max? Can you hand me one of those papers? Thanks. Okay, let's do the math while we wait for your timers to run down. What's your timer saying to you right now?
3 minutes.
Perfect. That should be just enough time to do this together if we all help each other out and do this as a team. So that means everybody needs a calculator. You can open up a calculator in your Chromebook, or I had some in the front row that were sterilized by previous students, but just in case, you may want to sterilize them, right? So everybody's going to be doing calculations. So make sure everybody has a calculator. If you don't know how to do it, I will explain it again after I call on you. Okay? So let's look. Here we have calculations that are needed for surface area. You guys see that? There we go. A 4 centimeter cube surface area, a 3 centimeter cube surface area, and a 1 centimeter cube surface area. What I would like you to focus on is I would like you to focus on doing the math for whatever size cube I assigned to you. So you're saying to yourself, Mrs. Hale-Manson, I don't know how to calculate surface area because that's geometry and we haven't covered that yet, right? Okay, so here's how you do it. You take the length of a side. So for this, it would be 4, 3, or 1, and you square it. So what does that mean? That means 4 times 4, or 3 times 3, or 1 times 1. And then you multiply it by 6. Where does that 6 come from?
The amount of sides on a
The amount of sides on a cube. That's how you get your surface area, okay? So whatever size cube you have, calculate your surface area. And then the next thing you're going to do is calculate your volume, which is length times width times height. When do you guys learn how to calculate volume?
couple years ago.
A couple of years ago? Okay. So if you never learned, there you go. Go ahead and do it. This is a square, so all the sides are the same. So for example, this would be 4 times 4 times 4, or 3 times 3 times 3, or 1 times 1 times 1. Okay? All right, so that shouldn't take you too long. Where are we in our timers?
40 seconds.
Okay, all right. So go ahead and do the calculations. I'm going to tell you what you're going to do next. Once your timer goes off, after 5 minutes of soaking has happened, you're going to walk to the back sink with your cup in hand. Eyes on me, quick explanation so you can do your calculations in a second. Sorry. You take your cup that's filled with vinegar and your cell, you put your hand over the sink, and you dump your cell into your hand, okay? And then you take your cell and you put it on the 3x5 card, okay? So if you didn't get one, you can get one now, or you can have 2 when you come back because it might be a little juicy, right? You can leave your cups back here to be sterilized later, and you can bring your cell on your card to your desk. What you want to do is cut it in half right away and measure the depth of diffusion with your ruler in centimeters, okay? So 2 things are happening right now. You're finishing your calculations for your cell, or maybe the other cells as well. And whenever your timer goes off, you can empty your cell into your hand, bring it back, and cut it. Paper cups can go in the garbage. Plastic cups I'm going to reuse and sterilize. Yeah, this room stinks of vinegar. at the end of the hour, you can wash your hands.
It's so big.
If you dislike the smell of vinegar.
Wait, my hands are. Oh god. This is like my.
Vinegar is sterile. Vinegar kills coronavirus. Yes, it does. Now you cut it in half and measure the depth of your diffusion with your ruler. Measure in centimeters, please. Do your best to estimate. I know our timing isn't perfect and our ability to measure isn't, whoa, don't knock my camera. Your elbow is really close to that camera. Don't give me a heart attack there.
Measure how much.
It does not have a case on it.
Pretty much.
So surface area, look, I wrote how you're going to do it right here. Okay, so just punch that into your calculator for whatever size you have.
I have half a centimeter.
The formula's up here. Yep, about half a centimeter is what usually people get. So remember to use the edge of your ruler. So we're measuring in centimeters, right? So this would be, 0.5 centimeters, 0.6, 0.7, 0.4. This has chemicals in it. It has a base and an acid in it, so you're not going to eat it.
Base plus acid equals neutral.
Somebody else's chemistry. It's not neutralized all the way though.
How basic is it for
And so a base with an acid creates neutrality, but it also creates salts, and there's lots of salts that are caustic. So just because you get water and a salt when you combine an acid and a base doesn't mean that you can eat it. Remember that.
You can eat anything.
You could die if you eat things too, and we're not going to do that in my class. Okay. All right. So can we share? So that you don't have to do all of the math, you're filling in the other answers as students tell you what they got. Raise your hand if you had a big cube. Big cubes, raise your hand. There should be like 5 or 6 of you raising your hands, maybe 7 of you. Okay, good. Can you guys all yell out what you got for surface area? 1, 2, 3, yell it out. 96 centimeters squared. And then what about your volume? Yell that out on 3. 1, 2, 3.
64
centimeters cubed. Thank you for putting units on your numbers. That is a good scientist right there. I appreciate that. Okay, medium cubes. Raise your hand. Where are my medium cubes? You should have your surface area and your volume calculated. You ready to yell it out? All right, surface area for the medium cube. Yell out your guess. It's okay if you're wrong.
54.
54. Is that what everybody got? 54? Yes or no? Is that what everybody got? Good. And then your volume for your medium cube. Yell out your guess.
27.
27. 3 times 3 times 3 is 27. Now the teeny cubes. Raise your hand if you had a very small cube. You had the smallest cell possible. Okay. What was your surface area? Yell out your guess.
6 centimeters squared.
Yes. And then what is your volume?
1 centimeter.
1. That was crazy. You guys had crazy math problems there. How did you handle that? Okay. Now let's make ratios out of these so that we can understand the comparison. Okay? So we're going to put surface area to volume. So the surface area for the 4 centimeter cube is 96. And we're going to create a ratio to its volume of 64. Now in order to compare apples to apples, we need to reduce that ratio to a 1 to something reduction. Okay? So I found that my students might need a little step in between that. How far can you reduce this? Oh, I'm sorry. You guys say simplify, don't you? Sorry, I'm speaking East Coast talk. Does any of your math teachers say reduce?
No.
I have been taught by my previous students that they teach you and they use the word simplify, okay? So can you simplify this ratio, please? Use your calculators if you need to. Yep.
Oh wait, never mind. Give me a number.
Okay. Yeah, so we can simplify it to 3 to 2. Now I asked you guys if you could simplify it even more so that all of our ratios are something to 1. So what would that have to be? You want to take a guess? If we can simplify this to something to 1, what would that be? 1.5. Good. Okay. That's the hardest one. They get easier after that. The next surface area to volume ratio is 54 for our surface area of that 3 centimeter cell to 27 for our volume. So that cell had a surface area of 54 and it had a volume of 27. Let's make that a ratio so that we can compare it to the others. What ratio could we reduce that to? I mean, simplify. My brain can't change courses.
2 to 1.
Yeah, it would be a 2 to 1 ratio. Last one doesn't need any simplification. It's already something to 1. Okay? So now when we look at all of these, as we increase in cell size, we go from a surface area for the 4 centimeter cube of 1.5, a 3 centimeter cube, which is smaller, to 2, and then the surface area gets even bigger when we have a very small cell. Okay? So the surface area to volume ratio, what happens to the amount of surface area as the cells get smaller? Increase or decrease? Let me repeat that question and you're going to yell out your guess. As cells get smaller, what happens to the surface area? Bigger or smaller? As the cells get smaller, what happens to the surface area?
Bigger.
It gets bigger. Kind of crazy. Let me draw you guys a visual. If we have the same volume, let's just say that this volume is 1, right? In that same volume, if I were to have, instead of having 1 big cube, if I were to have 9 little cells, can you guys see how I would have more surface area if I got smaller in the same volume? Does that make sense? You see that? So why would that be beneficial for cells to be smaller? What do they use that surface area for? They'd be more efficient in taking in the nutrients. Can someone with a small cell bring it up so I can lay out all 3 sizes for everyone to look at because it's pretty dramatic. Oh, you're gonna lose it. And then bring up a medium, please. It's okay if you cut it in half. You guys see that? Thanks. And then can someone with a large bring it up, please? Don't worry, you'll get it back and you'll get to smush it at the end. Now everybody wants to smush them.
I'm just hungry.
Do you need some food? I can give you some food. He's like, I just want to eat some food.
Just one.
Okay, can you guys see those? Are those all in your view? I mean, adjust the camera a little bit here.
Somewhat.
Okay, can you guys see that? What if those were cells? What would happen to the organelles or the structures on the inside of this cell? They would die. Why? Why would this cell allow all of the things on the inside of it to survive, but this cell and this cell would not? Yep.
Some membranes are too thick and nothing can get through them.
Are their cell membranes different? Are these all made of the same medium?
If it's too big, you can't get things to get into it.
Because they don't have enough what?
Kinetic energy.
They all have the same kinetic energy. They all have the same materials. What's the difference between these? The surface area, right? The surface area to volume is higher for the smaller cell, right? They've got more surface area if cells are small. Yep.
If that's true, why are there some unicellular organisms that can be like 3 or like 5 inches large?
Well, there's a certain limit, right? I don't know of any unicellular organisms that are 5
The
inches
saber
long.
There's
Look at that.
there's like this like weird one that can like grow in like lakes.
And it's one cell?
It is a single
Oh man, send that to me, can you please? I love
Yeah.
anomalies like that.
Love it.
Oh, not right now. I'll look at it in a little bit, okay? Is it really long and thin?
No, it's a
No.
ball.
It's a ball.
It's a grape. It looks like a big grape.
Isn't it
Okay,
called like a
I'll
ball?
look at that and then we'll chat about it tomorrow. Remind me to chat about it tomorrow, but I gotta look at it to see what's going on with that guy. Okay, so this is why if we need to have more surface area in certain areas like the lungs, the alveoli have all those little tiny air sacs in the lungs instead of one big lung, right? If we had one big lung, we wouldn't have very much surface area for the same amount of volume. If we have tiny cells, we have more surface area so that they can exchange what they need to survive. So if the vinegar was what they needed to survive, then you can see how this cell was able to get all of what it needed to survive, and these cells did not. That's kind of the picture. Now let's get these numbers down. I will tell you, just to make sure you guys get the post-lab questions right, these are all the same medium. You added all the same vinegar, so the depth of diffusion should be the same for all of them, okay? So everybody yell out what they got for their depth of diffusion. How deep did it diffuse for you? Everybody yell out a number right now. Go. Half a centimeter, 0.5 is kind of what I heard. So it should be the same for everyone. And don't worry about if yours was more or yours was less. This is not a very precise lab, but it's a fun lab because these things are really mushy and fun. Okay? So no matter what size the cell, the ability for the distance to travel inside the cell is going to be the same. Okay? Because the cells are made of the same cell membrane, no matter whether we're talking about bacteria cells or we're talking about elephant cells or plant cells. They all have the same cell membrane. Can you guys flip it over to the back? On the back, it asks you to draw a picture of, I drew a picture already, of the different cells. They're right here. And I know you don't have a pink marker. I just happen to have one because I've got supplies. Maybe you do have a pink marker. So go ahead and somehow show, this could be just shaded in with whatever color utensil you're using. So show that the 1 centimeter cell was able to have the vinegar diffuse all the way through, okay? And that you don't have to measure this out or anything, it's just a sketch, okay? The medium cell had some diffusion, but there was still some areas that didn't get any vinegar. And the same thing with the big cell.
What if you're doing
If you're doing it, then you can choose insert and draw. You can drop in a shape and then drop in another shape and then fill in that shape, okay? It's pretty easy to do. It's a good thing to learn too, especially if we're doing things digitally all the time. All right, what you need to do now with the remaining time is answer these post-lab questions. I will tell you, if you guys listened in this discussion, we answered all of these questions. Labs are not quizzes, so feel free to ask, hey, Mrs. Holmanson, did I answer this correctly? So as you're answering these, if you have questions, just ask me. If you're able to finish these in the remaining time, great. If you're not able to finish them, finish any questions for homework, okay? With that being said, let me tell you where to put your supplies. Cups can go in the back sink or they can go up here. Razor blades, back sink area, okay? Paper cups can go in the garbage. Your agar cubes can go in the garbage. I'm actually going to reuse your plastic knives. I'm going to sterilize those. And if you could yourself, please sterilize any calculators or rulers that you borrowed before you put them back in the community bin, okay? If you want to, now would be a good time to poke at your cell. If you want to come up and grab your cell, if you loaned me your cell to show the class, you can come get it. Otherwise, I can toss it for you. But if you make a mess, like you get any of the agar cube on your desk, please clean it up.
Might like to have another one.
Yes, any of these, if you guys want to, they're all going to be thrown away. They don't last very long. Okay. Yeah, just throw them away whenever you're done poking at it or whatever you want to do. Is that the right one for you? Yeah. Who gave me their little cell? Max, you want me to just throw it away? All right. It's very satisfying, isn't it? It's a fun medium.